One of the primary groups or divisions of the animal kingdom is the soft-bodied mollusca, which includes the cuttle, oyster, snail, etc. This group is divided into 5 classes, of which the one we must especially consider is the cephalopoda, or head-footed. So named because the organs corresponding to the foot in other mollusks are attached to the head, forming a circle or coronet around the mouth. Some of these creatures have the foot divided into 8 segments and are thus called octopoda. Others, in addition to the 8 feet or arms, possess 2 longer tentacular appendages, making 10 in total, and are consequently called decapoda. Among the 10-footed section of the cephalopods, there are 4 families, only 2 of which are found in Britain, the Teuthidae and the Sapidae. The Teuthidae include the calamaries, popularly known as squids, and are represented by the long-bodied Loligo vulgaris, which has, along its back, a translucent, gristly internal stiffener shaped like a quill pen. From this, and its ink, it derives the names calamari, from calamus, meaning pen and ink fish, and sea clerk. The Sapidae are generally referred to as the cuttles proper. As a type of this family, we may consider the common cuttlefish, Sepia officinalis, which possesses the hard calcareous shell often washed ashore and known as cuttlebone or sea biscuit. It should be noted that these head-footed mollusks are not fish any more than lobsters, crabs, oysters, mussels, etc., commonly termed shellfish by fishmongers, are fish. Thus, the word fish is misleading and should ideally be avoided. Furthermore, the names cuttle and squid as distinguishing terms are unsatisfactory. The word cuttle is derived from cuddle, meaning to hug or embrace, in reference to the animal's way of seizing and enclosing its prey in its arms. Squid is derived from squirt, due to its habit of squirting water or ink. However, as nearly all known members of this class, with the exception of the pearly nautilus, Nautilus pompilius, share these behaviors, these terms are not particularly apparent. Nevertheless, as they are conventionally accepted and understood, I will continue to use them. As with other mollusks, some cephalopods have shells, while others are naked or possess only rudimentary shells. The argonaut, or paper nautilus, has been regarded as analogous to the snail, which secretes an external shell to protect its soft body. The octopus is similarly compared to the garden slug, which has organs like those of the snail, but no shell. Cuttles and squids may be likened to certain sea slugs such as Aplysia and Bolea, and to land slugs such as Parmacella and Limax, which have an internal shell. The argonaut and other cephalopod families fall outside the scope of this treatise. We will, therefore, focus on the 3 families mentioned above. Regarding the anatomy and homology of the octopus, sepia, and calamari, we will discuss only as much as is necessary to highlight their similarities and differences in order to better understand to which of them the legend of the Kraken likely owes its origin. The octopus, sepia, and calamari all share a fundamental body structure. A bag of muscular, fleshy skin, called the mantle sac, contains the internal organs, heart, stomach, liver, intestines, a pair of gills, which extract oxygen from the water, and an excurrent tube through which the deoxygenated water is expelled. The forceful expulsion of water through this siphon tube serves as the principal means of locomotion during swimming, propelling the animal backward. Contrary to popular belief, this motion does not result from the expelled fluid striking the surrounding water, but from internal fluid pressure pushing the creature in the opposite direction. Connected to this siphon tube by a special duct is the ink bag, from which a jet of intensely black fluid can be discharged at will. I am skeptical of the claim, cited by Pontoppidan and others, that cuttlefish eject their ink with the intent to ambush prey or attract fish drawn to its musky scent. During the extensive period I observed these animals at the Brighton Aquarium, I never saw such behavior. I believe ink emission is a fear response, used solely as a means of concealment from perceived threats. Among its kind, sepia is particularly timid when first captured. Its sharp, unwinking eye reacts to the slightest movement, and even the most cautious glance from above provokes a release of ink in swirling, voluminous clouds, resembling smoke from a ship's cannon and quickly darkening the surrounding water. Yet, like its fellow cephalopods, sepia is highly intelligent. It soon learns to distinguish between friend and foe and eventually becomes quite tame, ceasing to eject ink unless provoked. Due to the connection between the ink bag and the locomotor tube, the release of ink is accompanied by a strong jet of water, allowing the creature to escape while simultaneously darkening its path. Oppian aptly described this behavior. The endangered Cuttle thus evades his fears, and native hordes of fluids safely wears. A pitchy ink peculiar gland supply, whose shades the sharpest beam of light defy. Pursued, he bids the sable fountains flow, and, wrapped in clouds, eludes the impending foe. The fish retreats unseen, while self-born night, with pious shade befriends her parents' flight. Professor Owen remarked that the ejection of ink in cephalopods serves as a visual defense, just as some mammals rely on odorous secretions for protection. Notably, the pearly nautilus and its fossil relatives lack this method of concealment, as their strong external shells suffice for defense. From the sac-like body housing its organs protrudes a globular head containing a brain and equipped with a pair of strong, horny mandibles, which bite vertically like a parrot's beak. These mandibles tear and partly chew the flesh of prey. Inside lies a tongue covered with retractable, recurved teeth, similar to those of the whelk, limpet, and other related mollusks, that help draw food into the gullet. Encircling the head is the organ corresponding to the foot in other mollusks, the part by which slugs and snails crawl. In cephalopods, however, the head is centrally placed, and this organ is divided into flexible, segmented arms radiating outward. These arms, capable of motion in every direction, function as prehensile limbs to grasp and secure prey. To enhance this ability, the inner surfaces of the arms are lined with rows of sucking discs. Each disc contains a retractile piston that can create a vacuum, allowing the arm to cling firmly to any surface, whether it be stone, fish, crustacean, or even human flesh. Although all head-footed mollusks share this basic body plan, it is elegantly adapted in each species to suit its lifestyle. The octopus, for example, is a shore dweller. Its soft, pliable, yet durable body, lacking more than a rudimentary internal shell, a small style, is well suited to squeezing into rocky crevices. In such an environment, a large, rigid internal float like the sepiostaire or the long, horny pin of loligo would be a hindrance. The octopus's 8 powerful, flexible arms are ideal for climbing over rocks and stones. Its primary food source, the shore crab, is plentiful in these habitats, and its broad, unarmed suckers are perfectly adapted for forming airtight seals on the smooth shells of crustaceans.